a fun little stream that I'm going to do today, which is Tashin's Clojure Challenge. My friend Tashin Fogelman from Twitter has challenged me to do the first Project Euler problem in Clojure, which is a language I sort of know, but not particularly. So I thought I would stream my solution, and we'll see where it goes. So first things first, I suppose I need to figure out how to run Clojure. I kind of haven't done this in a long, long time, so I guess we need to do that. We also need to register for Project Euler because might as well actually submit my problem. So let's do it. Let's be David Factorial. Let's do a password. Let's see. I'll get my LastPass account going. I will generate a secure password, not showing anyone what the word is to this password. And then I will paste it in here. And then I will type the conformation code. Very good. And I suppose I accept your privacy policy. Very good. Very good. You have been successfully created. Lovely. 79020. Yes, remember me, please. Okay, so there we go. Now, I am also familiar with this website, but haven't really done much with it. So perhaps the purpose of this was to inspire me to start solving the Project Euler problems, perhaps. But we'll start with the first one. So multiples of 3 or 5. The problem is as such. If we list all the natural numbers below 10 that are multiples of 3 or 5, we get 3, 5, 6, and 9. The sum of these multiples is 23. Find the sum of all the multiples of 3 or 5 below 1,000. So let's consider what we would do with this. Let's just do a little to-do .markdown file. So we did register for Project Euler. We'll need to install Clojure. We'll need to figure out how to run Clojure, and then we'll need to solve the problem. And then I suppose we'll need to submit the problem. So if we list all the natural numbers below 10 that are multiples of whatever, so let's move the I guess I've already done this one. Solve the problem is kind of a subheading. Wait. Okay, so let me make sure I understand this. So if we list all the natural numbers below 10 that are multiples of 3 or 5, we get 3, 5, 6, and 9. So all numbers below 10 that are multiples of 3 or 5, the sum is 23. Find the sum of all the multiples of 3 or 5 below 1,000. So you'd find all the multiples. If we list all the natural numbers below 10, the sum of all the multiples. Yeah. So you'd find all the multiples of 3 or 5. Iterate over each one. Well, in a procedural style, you would iterate over each number. If I was solving this in Python, say, maybe I'll solve it in Python first because this will be a functional solution. But I could say, if this was Python, I would say something like for I in range of 1,000. If I don't even know what the I mod 3 equals 0 or I mod 5 equals 0, then you would like sum equals 0 and then sum plus equals I. And then I guess you could like put this in a function. call it main, I guess, since we're kind of hard coding this. And then I guess we'll return sum, and then we could like print main. And then I suppose you could parameterize this and all kinds of good stuff, but for now that'll work. I mean, yeah, you could call this like sum of 3s and 5s below, and then you could pass like the max, and then you could like do a range. Although now I'm like using a bunch of built-in names, it just feels a little more interesting. So that's, I actually feel like that would probably work, or there's probably an off by 1 error in there somewhere, but I think that's the idea. List all the natural numbers. That means like integers that are below 10. We get 3. It's the sum of the multiples. Find the sum of all the multiples of 3 or 5. Below 1,000. So below 1,000, I believe this goes up to but not including the number. So yeah, I think that would work right there. Let's just try running this, I suppose. Yeah, Python main.py. Can't open the file. There we go. Okay, so the answer seems to be 233, 168. So I suppose what we could do is we could actually try just putting our number in, 233, 168, and then like make sure that we've got the answer. Did it work? You are not permitted to get, wait, did I type that right? 233, 168. Account. Emergency recovery is not yet available. Did it work? I assume that was not right. All right, 233, 168. Did I read that correctly? If we so, wait a minute. Define natural number. Yeah, set of positive whole numbers. Yes. So sum of all the multiples of 3 or 5 below 1,000. Sum equals 0 for I in range of the amount. If I, wait a minute, is this like one of those, is this one of those like precedence problems? I assume that will give us the same answer, yeah. Find the sum of all the multiples of 3 or 5. Is that what this means? The multiples of 3? Or do I have this wrong? Mod 3. Is it divided by 3? Oh, wait a minute. Math, how does it work? Let's see here. If I say, suppose that I have the number 3, and I say mod 3, that's, oops, that equals 0. So if I have 4, that gives 1. 4 is not, but 5 is 2. Then that would be like, yeah, so either of these. Did I type it wrong? That would be silly if I typed it wrong. I feel like this is the right answer. If it's either sum of all the multiples of 3 or 5, let's try printing them out and see if they look reasonable. Oh. Oh, wait. Or no, yeah. That's right. So are these numbers all multiples? Let's just go to the top and start checking. So is 0, well, 0 doesn't add anything to the sum. Is 3, yes. 5, yes. 6, 9, 10, 12, 15, 18, 20, 21. Yep, this looks like it's right. So find the sum of all the multiples of 3 or 5 below 1,000. Am I adding up one too many or something? No, because 999 is the last one. 233,168. 233,168. Oh, okay. I guess it worked that time. Well, we guessed we went over it again, I guess. The answer you gave is right. Neat. This has been solved by nearly 1 million people. Difficulty rating of 5%. Indeed it was. Let's see here. So, now that I know what I'm looking for, let's solve this problem in Clojure as well. So, how would I do that? I guess we would go to Clojure's website. Where is the website for Clojure? This language has a reputation for being abnormally well designed. Clojure is a dynamic, general-purpose programming language. Well, that's good. Is it still Java-backed? I assume it probably... Yeah, JVM. So, how do I get it going? I suppose I will click the Get Started button and see how this goes. Getting started. Requires Java. Clojure officially supports Java LTS releases. Okay. 8 or 11. I have not messed with Java in a long time. On Linux. Yes, here we go. Oh dear, what is this going to do? How about I Arch Linux Clojure? Since that is what I am using. Don't really want to oh yeah, see, it's there. It's there. So let's do a nice sudo pacman-s Clojure repository extra. Do I want JDK, open JDK, JDK 11? I guess I want the first one. Or do I? No, wait. I want 11 because it said it was only 8 and 11 that are officially supported. This looks reasonable. All right, we'll roll with that. I don't know what the first one is. So, to run the REPL, install Leanigan. I have heard of this tool. Leanigan is the easiest way to use Clojure. So it is. Focus on project automation and declarative configuration. Ah, this is like, lets you run the thing. Is this also installed? Yeah, it is. Let us, wait, did it install that for me? No. So let's do Leanigan. I believe that name is like a fairy tale or something, or I would like to know what that is. Tell me, internet user. I mean internet. Yeah. It's this. Oh yeah. It's an ant joke. Leanigan versus the ants. It's because ant is the build tool for Java. Ha 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 ha. I get it. This is like a build tool. So, we installed that. Can I now say What was it? How do you do it? You say, I guess we've installed. All right, how about learn Clojure? Wait a minute. How do I run something? I guess I could, yeah, how do I run hello world? Depths and CLI. I suppose I could also have used Replit, but that's not as cool as running it locally. Let's show me the docs for this. Oh, it's right there. That's the docs. No, the tutorial. What's your tutorial looking like? Technomancy. That's an excellent. Excellent. So, leaning again is for automating Clojure projects without setting your hair on fire. Lovely. I'm glad to hear it. Yes. Could be thought of as Maven meets Ant without the pain. Okay. It combines Ruby gems, bundler and rake, and pip/fabric in a single tool. Well, that's cool. Lean again works with projects. A project is a directory containing a group of Clojure source files and with a bit of metadata about them, stored in a file named project.clj in the project's root directory. Okay. So I could say a new app. I mean, am I going to make an app? This is like a single file. Is this required? I suppose I could list like lean new app. So lean new app. How about Euler 1? What's this gonna do? Oh man, we're installing jars. Oh my goodness, we've got we've got source files. Okay. I feel like this microphone is in my way. It's like right where I want to look. All right, there we go. So then now, I guess I could like open this in Vim. Or wait, I'll open it in this way. Docs. Yes, we have some great documentation. We've got some. Although honestly, this is kind of cool to have like docs, resources, the source. The tests, I suppose that's yeah. Okay, fine. I could do some tests. Def main, gen class. All right. The change log. Oh. See, Clojure is a very nicely designed language, as far as I have heard, and so it doesn't surprise me that their build tool would be quite nice. I feel like this type of thing where they add automatic like docs and stuff for you is like a good way to get people to actually do it. Ah, the Eclipse license, interesting. I guess that's fine. So, description, all these things. The readme, here we go. So, you say java.jar, my goodness. All right, let's see if I can run this file. If I like indent this, yeah, okay. So now I can say what? Directory layout, dependencies, overview, snapshots, checkout, dependencies, running the code. Yes, lean REPL. Lean run. There we go. How about it? No main namespace specified in project dot Clojure. Where's that? Main. Okay, wait. We haven't written any tests. We can run the failing tests, including the project template. Does that do anything differently? Probably not. Nope. Couldn't find project. Oh, wait a minute. We have to go in here. Oh, is this the problem? I'm in the wrong folder. Yeah. There we go. So we got a nice fail. Can I run now? Oh, okay. We got it. So then does Vim test know how to do this? Test requires fireplace.vim to run Clojure tests. Okay, well, let's not worry about that yet. Acquire the test and other stuff. So now then, I guess I need to learn Clojure. So in this case, go to our learn Clojure section. And okay, so we've got so this is a Lisp, a semi non-standard Lisp, I guess, but a Lisp nonetheless. I have used Common Lisp back in the day, a little bit of Emacs Lisp, but have not really done any recently. So we'll see how this goes. So semicolons are comments. Character types, we get the string with double quotes. Symbols and indents. Symbols composed of letters, numbers, and punctuation. Right, okay. 3 special symbols that are read at different types. Null is null value, true and false are booleans. Literal collections. Right, so you've got list. This is a standard Lisp thing. You got the quote mark to show this is a list. You got a vector. You got a set, and you got a map, okay? No commas between items. How do you read and evaluate expressions? You say read as characters into the compiler, which produces bytecode. For Clojure, though, read by the reader. Okay, the reader may read the source either from Cloj files or by giving a series of... The unit of source code is a Clojure expression, not a Clojure source file. Source files are read as a series of expressions, just as if you type them interactively at the REPL. Very good. Separating the reader and the compiler is a key separation that makes room for macros. Macros are special functions that take code as data and emit code as data. Yes. That's a fun aspect of a Lisp. This diagram illustrates the difference between syntax in green and semantics in blue. Very good. Right. Most literal Clojure forms evaluate themselves except for symbols and lists. Symbols are used to refer to something else. When evaluated, return what they refer to. Lists are evaluated as invocation. Right. So 3 and 4 evaluate to themselves, plus evaluates to a function. Evaluating the list will invoke the plus function with 3 and 4 as arguments. Indeed. Many languages have both statements and expressions, where statements have some stateful effect but do not return a value. In Clojure, everything is an expression that evaluates to a value. That's kind of cool. Some expressions, but not most, also have side effects. Right. Let us consider how we may interactively evaluate expressions. So, delaying evaluation with quoting. Sometimes useful to suspend evaluation, particularly for symbols and lists. Sometimes a symbol should just be a symbol without looking at what it refers to. Right, so that's like it's like a string, but it's not a string. It's just like an identifier. Sometimes the list should just be a list of data values, not code to evaluate. Yes, one confusing area you might see is a result of trying to evaluate a list of data as if it were code. Long cannot be cast to a class, right? All right. The REPL. Most of the time when you're using Clojure, you'll be doing so in an editor or a REPL. Read an expression to produce Clojure data. Evaluate the data. Return from number 1 to yield a result. Print the result. and loop back to the beginning. This is the read eval. Print loop, yes. Most REPL environments support a few tricks. *1, *2, okay. There's a namespace Clojure.REPL, which is included in the standard library. Very good. So, based on what we've heard before, this is a function, and this is an argument. Okay, so there's a quote mark, and this is like a list, a vector of things. Interesting. The doc function displays the docs for something, right? Can invoke doc on itself. Can also widen your search to include the doc strings. Okay. Very good, very good. Def. When you're evaluating things that are REPLs, you will save a piece of data for later. So the def is like const or let or something, or wait. In most actual Clojure code, vars should refer to either a constant value or a function, but it's common to define and redefine them for convenience in working the REPL. Yes. Thus the return value is user x. That's a literal representation for var, followed by a namespace symbol. User is the default namespace. Gotcha. Cool, cool. Print out values. Oh, that's kind of cool. Pern and per for data, and then print ln for humans. Very good. Test your knowledge. Okay, let us, in fact, test our knowledge. Using the REPL, compute the sum. I'm going to, move this over a little bit. And then I'm going to take this, and I'm going to go like this a little bit. Very good. Very good. So, how would we do this? Where'd you go? So, our main function here. Let's see here. The main function appears to have a doc string, what is that, like a list of arguments or something passed in from the command line, and then the body of the function. So let's go something like, this wanted me to use the REPL. So lean REPL. Something that I was sad about with Clojure is that stuff seems to take a while to get started. But that's okay. What is this? There's a... Although maybe it doesn't really matter if it takes a while to get started. How do you turn on the REPL there? I thought that was it. To run the REPL, do that. Ah. Oh, I didn't wait long enough. So then is it faster the next time or something? I guess it's fine. So, compute the sum of 7, 6, 5, 4 and 1, 2, 3, 4. Very good. Got it. Still got it. So, interpret this as a Clojure expression. That would be slash the quantity and then 10. And the quantity then is 7 plus 3 plus 7 and times, or wait a minute, 7 plus the quantity times 3 and 4. And then I suppose you can have 3 arguments to the plus operator. Is that it? Oh wait, I have too many prints. This, yes. 12/5. Huh. Oh, that's kind of cool. We'll assume that worked. I'll check my answers. Looks like I got it. Using REPL document to functions. Oh, I'll need that. Doc mod modulus of num and div truncates towards negative infinity. All right, so I could say mod of some number like 7 with 3, which is something we needed. Very good. Is there like an equal function or something? All right, so there's the syntax, functions. Clojure is a functional language indeed, in fact. Most code consists primarily of pure functions, which I believe is what we'll be doing here as well. Invoke a function with the name of the function and function position. Yes, multi-arity functions, right? Or wait a minute. So we've got the function, we got the name. Okay, so I'm going to need this. Can I use this in the REPL? Def in greet name stir. Hello, what is it? Hello, comma, name. And then I can say greet David. And so in fact it does work. So the stir function concatenates. Very good. Multi-arity functions. Oh, cool. That means, so with 0 function parameters, it just says hello world. With 2, it does, okay, so I could say something like, if there's no parameters, do messenger. What does that mean? Oh, I see. Let's call it. Oh, we got some nice recursion going here. Greet David. Otherwise, so I could say greet. No. Arity exception. Wrong number of arguments. I thought I had one that was none. Or do it? Oh, wait a minute. Now here's the part where you know, we need lots of parentheses. There we go. And that works. Okay, so that's reasonable. Variadic functions. Variable number of parameters. That's the ampersand, I see. Which puts it into, right, a little list. Anonymous functions with fn, yes. Def in as a contraction of def and function. Oh, makes sense. Anonymous function syntax. Percent signs for the, oh, okay. But one common need is for an anonymous function that takes an element and wraps it in a vector. We try writing that as. That expands to that. This will wrap in a vector and try to invoke the vector with no arguments. Instead do that. Okay, very good. Syntax corner cases, eh? The apply function invokes a function with 0 more fixed arguments and draws the rest of the needed arguments from a final sequence. The final argument must be a sequence. All 4 of these are equivalent to that. Okay, so apply is when arguments are handed to you as a sequence, but you must invoke the function with values. Very good. Let closures. Lovely. All right, so tell me about collections. Clojure collections collect values into compound values. Very good. There are 4 key Clojure collection types: vectors, lists, sets, and maps. Of these 4 collection types, vectors and lists are ordered. Yes, so vectors are indexed, sequential data structure with square brackets. Indexed means that you can do that. Hello, Datafi. I am learning in Clojure to participate in my friend's challenge, who has challenged me to do the first Project Euler problem in Clojure. So that is the goal. I have officially done it in Python, and now I am attempting to do it in Clojure. So yes, it is a fun language, a very practical Lisp. Are you familiar with this language? I have a lot of respect for this language, since it was, seems that it was designed very carefully. I've enjoyed listening to a few of Rich Hickey's talks. So you can, use the get function to retrieve an element of the index. Yep. Count. So we're going to need adding elements. Okay, immutability, lists. Here's where we're going. I need to sum the elements of a list, basically. So wait a minute here. I want to sum all of the numbers. Where's my main.py? How would I write this in Clojure? Because instead of looping, I'm going to basically map. I need the numbers 1 through 1,000, and then I need to map this over it for each number. If it is a multiple, I could have it be the number otherwise 0, and then I could sum those. Okay, that's what I need. So then do you have, where's my, how about Clojure list functions? I assume this is something I want. Yeah, here we go. There's the list function. Is there like a... Or, no, that's a... Okay. Is there like a range, perhaps? Yeah, lazy sequence of numbers from start to end by step. Yeah, that's what we want. Very good. So let's go back to the... Okay, I may have enough to get here. So that's just a lazy range. Oh no. No, don't print it. Oh no, what have I done? It doesn't protect against this. Oh no. What would this be? Kill all lean? Kill all Java? There we go. I thought like in Haskell it doesn't do that. Although no, it does, doesn't it? Yeah. Because I tried to print the value of an infinite sequence. Okay, fine. Let's try again. How about range to 100? Much better. Excellent. Okay, so then let's do. Okay, so got this. Now, is there a map or something? I feel like where's the where are the list function list? I guess this is the core. Yeah. This is what I want. Is there like a map? Well, I'm like missing some UI or something because of my. Look at the quick ref. Yes, please. I would like some quick ref. Wait, is this what it? Yeah, okay. So, Boolean strings, flow control, delay, function based, concurrency, general. Is there like array list, vectors, list? Here we go. Create a new list. Lovely. These kinds of things. Maps, sets, iterations. Where's the range function? In the sequences list. Okay, here we go. So then... Yeah, I would assume there's a map function. Is it in here somewhere? Iteration, here we go, yes. Returns a lazy sequence consisting of resulting this stuff with this stuff. Okay, very good. So I could say, take this, map the function over collection. Very good. So I'll say map my something over this. I guess I could try using one of those fancy app is used with the hashtag. Oh, interesting. Not gonna get into macros today. Yeah. Let's use fn of, let's take, what is it, like percent? If I said the modulus of 3 with percent, that's like, well, no, wait. Or is it like %1? Ah, gotcha. Oh, wait, what was the... Oh, okay. Oh, function still takes... So it would be like... something like this. If I just kind of went like that, that would be a null op. Yeah. Or no op. Cool, got it. Very good. So then if I said mod of what? The number and 3? Yep. What's the preferred way to equal something? Is it like EQ? How do I search this? Looking for EQ. I assume that's it. Clojure equal EQ. In common Lisp there was like a bunch of different equality things. Just the equals operator. Got it. What are the differences? Equal is true when called with 2 collections if both arguments are sequent. Or no, wait a minute. 2 immutable scalars, both are that, both are. Okay, so that is what I want. What's double equals then? Specifically for numerical values. Oh, so like equal is like strict equal, and like that's false. Yeah, okay. But this is true. Okay, yeah. Got it. So then if I said I wanted this to only be where that is equal to 0, parentheses. Or wait a minute, what happened? Okay, now is the part where we take this into the editor. Or wait. And we'll go back here, and so I wanted to say def in what was it called? Sum of 3s and 5s. So we'll do some nice dashes since this is Lisp, and then I will add this in. So I'll take in the number, or the max number, and then, all right, give me this on some new lines. Function of number. We'll give that, and then sum that to. Yes, and so this makes it easy to see where my syntax error is. So yes, we're trying to sum, we're trying to sum all the numbers less than 1,000, which are multiples of 3 or 5. So if I map over the range of numbers from 1 to 1,000, and I say if it is equal to 3, return the value, basically. Otherwise return 0. So I need like some sort of like, a bit like an and or something, or and an or. Returns true if x is false, otherwise. Or no, not that. I guess I just need an if or a cond or something, or there's probably a more Clojure-y way to do this. How would that work? I want to filter. There's like 100 ways to do this, I suppose. Yeah. So I basically just want this. Okay, right. If is a function. That's neat. So I can say if this is true, then return number, otherwise return 0. Yes, and then, well, it'll be, oh, and then there's an or. Is that right? What is it? Or returns the value or something? Or no, wait a second. Hold up. I got this. I appreciate your pointers here. If or, I could see how this could become intuitive, but it's not right now. But it's interesting. Something like this, right? You got or, these two things. That returns true or false. If either are true, return the number, otherwise return 0. Oh man, this is actually looking like Lisp. That's exciting. And then there's a parentheses there. So that will return a full list of numbers. Or wait a minute, range of max. So then over here I can say print sum of 3s and 5s below 1,000, and that might do it. Well, that won't sum it yet though, but that will give. I'll see what that does. Goodbye, Clojure. Appreciate the friendliness. Let's run it. Oh, what happened? End of file. Oh, I have a. Do I have imbalanced parentheses? Yes, I do. Okay. Detafi, are you a Clojure programmer? And if so, what editor do you use? Is this like a Emacs is the right answer kind of thing? This may have been a reason I never used Clojure before. I've been a Vim person for a long time. But it always seemed like Emacs was like the one true Lisp editor, which was pretty sweet. This looks promising. 3, 5, 6, 9, 10. Yeah. So then all I need to do is sum this up. Oh, I think it'll do it. Tell J, okay. They've got a Lisp editor. How's that for your first ever Clojure program? No. We've got another syntax. Oh, wait a minute. You can't just, or can you? Is that how sum works? Sum. Map sum. That seems like it. Oh, well, I guess I can just, oh, no, wait, what? The plus function can just take as many parameters as you want it to? Does that work? No. Oh, I didn't actually. What did I do? This one. There we go. That doesn't work. I am casting something. Right, so now I need to. Yeah, doesn't. Maybe it is map sum. Or no. Okay, well I actually have to. Oh, apply plus to the list. Yes, that seems right. So I would say apply the quoted plus to the list. How about that? I like that idea. Wrong number of arguments. What, is there a maximum of like 21 arguments? Clojure sum a list. Sum of numbers in a list. Let's see here. Yes, I accept your cookies. Let read line map V. What is this? Look at that. Apply to the numbers. Do I need like a? Do I need a vector instead? Ah, apply the plus sign. Or no. Wait. Do I have? Is this quote not the right? Map V is a vector. Oh. Although that did work. Ah, it was because... Wait a minute. Why is that? Okay. This is the part of Lisp I never quite figured out, I think. Why is it that I don't want a quote here? I thought the quoting means don't evaluate it. But does that not matter if it's not the first thing in a parentheses expression? Because it's a second thing in the list of in the parentheses expression, it's not going to be interpreted as you evaluate this function. It's an argument. It's passing the function instead of the symbol plus sign. Well, I think it worked. That was the answer right there. Neat. I do believe I have officially solved the problem. I'm fairly happy with that function right there. Let's Project Euler number 1. That's kind of fun. Maybe I'll do some more of these at some point. My friend had challenged me to do the first problem. What is the second problem? So we got that. Progress. Yeah. What would you do to improve this then? Like, would you map V and then, like, what? Could you just plus it then? Does that work? No. Oh, a reduce. Oh, yeah, that's a good idea. Here, let's try that. You take the numbers. Reduce. Oh, sure. That's a good idea. Let's do version 1 and version 2. V1. Let's see here. So reduce would be what's the order of arguments in here? F is a reduce function which takes two things, val and collection. So if I wanted to do this, takes the function which could you like this. If val is supplied, returns the result of applying f to val and the first item in call, then applying f to that result. If call contains no items, returns val and f is not called. So the collection is the numbers. The let me try making another. Let's do like multiple 3, 5. And then I'll take that and move it in here. Or how would I do this? I go like that, and then could kind of do one of these numbers. So then you could do something like reduce if it's that, sum it to value is the start value. Okay, yeah, so parentheses. We'll just do that abomination for now. So the first, okay, so val is the start value, so that's like 0. And then this function takes 2 arguments. One is the turns the result of applying f to the first 2 items. Right, so this is like thing and or if call contains no items. If if val is not supplied, but if if val is supplied, returns the here we go. Returns the result of applying f to val and then the item. So it's accumulator and num. Yep. So then you've got this is kind of like sum and num, and so then I take that, I take this and I apply the function, which is going to add the sum and multiple 3, 5 num. That may not be the best name for that, but I think that is what I want there. So that says reduce on starting at 0 the numbers between 1 and 1,000, or 0 and 1,000. For each of the numbers, given the sum and the number in question, return the sum of the current sum and the value of this, which isn't very well named, but it's return the value of return the value if it's a multiple of 3 or 5, otherwise return 0. So actually maybe a better way of putting this would be like do you use like parent or question marks in Clojure if it's like a predicate, or is that something else? Where was this list of things? Yeah, you can do like the question mark things. Okay, cool. So multiple 3, 5 question mark, that seems a little more reasonable. So then you could say if, or no, it's just this. That's the whole function. And then you say or no, do you, if multiple 3, 5 question mark num or 0. That's, I'm not sure I'm going to get much better than that. So then sum of that. How do you rate that function then in terms of closureiness? Let's actually make sure it works. Oops. Sum of 3 and 5. I'll take it. If the first one was like a 1 or 2, then we're making progress. Okay. Let's actually see that it runs. We've got a syntax error, of course. So close to an optimal solution. Oh man, I'm here for it. Where's the syntax error? This is what happens. Okay, there we go. That's what happens when you don't have linting set up. Oh no, line 22. What happened? What happened? Def in, def reduce. Probably would help if this actually does compile. Oh, it would help. Okay, so parentheses. And wrong number of arguments passed to reduce. Why do you say that? Remove values not divided by 3 and 5. Ah, with like a filter or something? Oh, that does seem reasonable, doesn't it? Okay. Yeah. Why doesn't this compile? Oh, do I have something silly over here? What did it say? Number of arguments passed. One oh. This is doing something. Oh. That would probably make a difference. Does this run? Yeah, it does. Okay, cool. Cool. So now, where's my, oops. Where's my filter? Return on the sequence of the items. Oh man. Yeah. Oh. Then you do the yeah. This gets rid of the. Okay, so then we'll say version 3. Is this kind of the is this the zen of Clojure? You basically just keep doing this until you have non-messiness in your functions. Pull out the predicates, pull out the anonymous functions. That's cool. Huh. Okay, so let's see here. So then filter takes a predicate and a list. So okay, so I've got a good predicate. Let's just say range max, and then I want to take that and I want to say filter that based on. Oh, yeah. Then you just multiple 3, 5, range max. Oh, that does seem very nice. And then I take this and then I sum. Then I don't need the if anymore. Yeah. Then I just sum the numbers up. Oh. It's going to be on this collection, starting as 0. Just do a plus. Is that it? Reduce plus. Oh man. Oh, is that how you indent that? I guess so. Reduce, starting at 0, adding the numbers together, filtering. Oh man, how about that? Okay, so the final answer is basically. Oh, that is clean. I really like that. Yep. Very true. Well, cool. Thank you for your coaching. It was very helpful. I am going to post the final answer here then, I suppose. To Twitter and alert my friend that I have solved the problem with the help of a friend. Yeah, that does seem a lot nicer than the first version. It's a little all over the place. Yeah, I like that idea. All right, so how would I do that? So the version 1 is this. Yep. Yeah, I've played with functional languages enough to kind of know that there's a different way of doing things. Ah, that is really that felt very nice to write code like that. Let's do a little snip tool. Let's go. Version 1 is this. Where is my... Oops. So let's see here. I need to find the original tweet. I've joined a very enjoyable corner of Twitter, full of interesting people, and was challenged by a friend to do this. He was handing out October challenges based on what he knows of you. So. And he selected this for me. Where is it? Is that it? No. Where is it? I am, I feel like, this is a very, Twitter is a nice way to demonstrate something like this. You can tweet each of the steps. So let's see here. We've got, where should I post this? Here's his challenge. I guess I will quote tweet this. And I'll say my person, I have successfully completed your October challenge. User Detaffy in the chat helped me refine the solution. And I must say that the final solution looks pretty cool. And I guess we'll say this is version, previous versions. That's version 1. Then we'll say version 2 is kind of this, I guess. Yeah. New. We'll go here. Oh wait, we've got a thing in the way. There we go. There's version 2. And then finally, our grand, glorious version 3. Is this the best way to indent this? How would you do it? Like, I guess the number of spaces isn't particularly, like, I want this to be on a new line, so it's like not something like that. Or you like it before, like this? Yeah. What would an idiomatic closure be? Like this, I feel like is Python inspired. So we'll yeah, I think you're right. All right, so we'll go there. Yeah. And then the answer to... By the way, the sum of all multiples of 3 or 5 below 1000 is... The answer is 22,33168. There it is. I feel like I want to also post a video link if anyone felt inclined to watch this, just for publishing work, even if no one watches it. We'll see. All right, I think I'm going to end it there. So, thank you, Detafi, for your help. That was very fun. I feel like I've learned a little functional programming today. So, have a good one, and I'll see you later. Cheers.